Hello world, welcome to the stream, welcome to Coding a Roguelike in C. Probably not going to be a terribly long stream today because I only have a short block of time, but let's make it count. So, if you remember last time, we left off, we had implemented some movement for our monsters, some more intelligent movement based on our Dijkstra mapping implementation. We're basically having the Dijkstra map influence where the monsters should move for their next turn. But what we saw was that there were two things that we left undone. The first was that the monsters in their current implementation move towards the player regardless of whether they've ever seen the player. So it's basically like a countdown timer where while the player moves around, all of the monsters are converging on that player, which is not realistic. So we're going to fix that and have the monster move towards the player only if they've seen that player. And then furthermore, we're going to put like a little timer in with the monster that says they're only going to chase the player if the player is currently in view or has been in view in the last 5 turns. So if the player manages to run around the corner and stay out of sight for 5 turns, and I just pick 5, we can change it based on how it plays. If the player manages to stay out of sight for that long, then the monster will forget about that player, because monsters are dumb, and they do stuff like that. But again, we can play with that number 5. And then the other thing that we saw was the current algorithm, it picks the optimal move for its next move. But in our current implementation, depending on the position of the character and the monster, there could be 2 optimal moves. And so our current implementation always picks, you can see it right here, if the optimal move is to the left or to move to the left or right, we check that before we go, up and down. So basically, depending on the positions, we would get this kiting effect where the monster would never actually get closer to the player. They would just stay the same distance away, and kind of move parallel with the player. So what we're going to do to fix that is we're going to evaluate all of the cells before we pick one, and then if there are multiple optimal moves, we will pick randomly between them. So we're not just always going to pick the first optimal move that we find. And that should eliminate that effect that we were seeing. Yep. So let's jump in. Let's first determine if the monster has seen the player and if the player is currently in view, because in that case we always want to give chase. So the way that we're going to do that is we're going to assume that the player and the monsters have the same exact quality of eyesight, and if the player can see the monster, then the monster can see the player. And so we have a structure for that. I don't know if it's in this. I don't think that we've got a field of view map that basically we can check. I believe it's in this one. FOV. Here it is. We want to borrow like this. If FOV. And if it's greater than 0, then that means that it is currently in view. So let's borrow this code. Find our movement. Where are we? Okay, right here. So The player can see the monster. The monster can see the player. So what we're going to do is we're going to check. We know the we are so what do we want to be our P here? Position P right now is our current monster position. So I guess we can check that and say if the monster is currently in view, then okay, player is visible. Otherwise, we're going to have player is not visible. See if monster should still chase. And we'll get to that one in a minute. So if the player is visible, then we want to implement this logic. So we'll do a bool give chase, and we'll set it initially to false. And in the case that the player is visible, give chase is going to be true. And so then we'll protect this down here, determine new position. We'll do if give chase. Then we're going to move smartly, and then otherwise we'll maybe implement our old random movement, or maybe stay put. Based on our target map, yeah, we'll optimize that in a minute. Let's bubble this down. And so if the player is not currently visible, then we need some way to determine if the monster should be chasing them. So what I'm going to do is I'm going to write the code that I would like. So, well, first what we need to do is we need to figure out which component that should be a part of. Movement, obviously. That seems to make sense. You know what, we're not even taking movement into account yet. But this is the logical place for it, so we'll do... It's interesting. We'll have a chasing player, Boolean. Are we actually using this yet anywhere? I think we built it and allowed for it, but I'm not sure that we're... Oh, we're gonna need to add this, because this is our add component. So what we're going to want to do is copy chasing player, Destroying it. Okay, so floor, no, we don't use movement because floors don't move. NPC, we do add it. Okay, excellent. So what we're going to do is we're also going to set this chasing player equal to false. Default it to false. We don't want them chasing right off the bat. Wall add. And then we'll go back down to our movement. So now oh, you know what? We also need something else. But here's what we're going to do. So and we'll make it a pointer. MV equals and just like we do up here, game object get component. We want the game objects oh, do we already have? Oh, we've already got a reference up here. Because we're looping through the movements. That's right. We've already got one. So this becomes even easier. So we say if MV chasing player well, let's just do this. Give chase equals MV chasing player. And then what we're also going to do is we're going to have another data component. Moves. Hey, Core the Bird. How's it going? How's it going this morning? What is going on with you? So what we want to have in our movement component is we also want some sort of counter that indicates the last time that the monster saw the player. And then when that exceeds our threshold, we will cancel the giving chase flag, or the chasing player flag. So let's just do last or turns. Since I don't know, is that going to be? Some of these variable names can get rather long, but I'd rather be more descriptive than try and guess at what a variable is. A little bit of typing will save us time in when we come back later and try and figure out what it is that we've done. So turn since player seen, we're going to increment. And then we'll say if, so we get the autocomplete, which is nice. So we'll do 5, we said for now, or if it's greater than 5, we will say chasing player is false, but we're still going to give chase this turn. We'll give it one more. We'll give it one more chance. So likewise, when we see a player, we want to say move chasing player is true, and turns since player seen is going to be 0. Zero that out. Let's grab this and head back up to the component so we can add this in. And then we need to go back here. It's getting long there. Oops. Since turns since player seen. You see, I forgot the name of the property already. Alright, so turns since player seen. That seems reasonable. So they've seen the player. Just get rid of this to do because we implemented it. So now we've got, if the player can see the monster can see the player, and if the player is visible, then we're going to give chase. If the player is not visible, then if we've seen that, if we're currently chasing the player, and well, we set give chase to whether we're chasing the player, and then we check and see how many turns we increment the number of turns since we last saw the player. We check it, and if it's greater than this 5, then we turn off that flag, the chasing player, for next go round. And so now we also, let's see, give chase starts as false, so we set it to true here, and then we do give chase, so it could be true here. Now we're checking if we're chasing, then pick our optimal moves. We'll come back to that. Let's just right now go back to moving randomly if they aren't currently chasing. So I always forget this syntax. It's because I don't code C daily, and so it falls out of my head if I don't do it on a regular basis. Alright, so we're going to do pick a random direction, and we're going to pick a random cardinal direction, so there's only 4 of those, up, down, left, right, so we're going to mod it by 4, and then we'll do a switch direction. Case 0. Let's cut up all our breaks. So we'll just do this. Just pick these guys randomly. But what we need to do first, I think. Oh yeah, we check if we can move there. So once we set our new position, we test and see if it can actually be moved to, and in the case where it can't, we're just going to stay where we are. I skipped one. We got x minus, y minus, x plus, we need y plus. Alright. Let's do... We got a couple of build issues. It's telling me I've got a syntax error. I'm on 7.4. So, write this so you guys can see the code. 7.4. Oh, what is this, Pascal? Okay. Alright, equals instead of just a dash. And then 410, it doesn't like my FOV map declaration. That's interesting, because I thought that was a global. Oh, maybe I need to include FOV for game. Okay. I wonder if that's going to mess me up. Let me see. May have a circular ref here. So here's my FOV map right here. That's where I declare it. I think. Am I gonna run into trouble? Yeah, so I'm accessing the physical stuff here. I'm gonna have to promote that FOV map out of this file, which kind of sucks. So the problem is, I'm just doing like a Unity build or just like a single file build, so I'm including all of these files. I don't have headers. I just like include all the files together into one single compilation unit, and so the ordering kind of matters. If game is asking for FOV map, which is declared in FOV.c, yet I can't just flip-flop the order of the includes because FOV.c is dependent on things that are declared in game. So what I could do is just promote the FOV map variable into game.c. Seems kind of sloppy because I like to keep things somewhat separate. I guess I could do like an extern or something. For now, just this. Because this is kind of my world state up here, so it's not the grossest thing, because I've got my target map here, so I'll just have my FOV map here too. Alright, so that'll clean up my, that'll clean up my build errors. So let's run this thing and see what we've got. Alright, so the monsters should not be moving towards me right now. They should only, once they see me, start moving towards me. So let's cautiously go through and see. And they're moving randomly now, probably. That's what the algorithm would indicate, because they're not giving chase. Yeah, where are these guys? Oh, there's one. Okay, so now it should chase me. And it appears to be chasing me. So now let me see if I can stay out of sight for 5. I should probably go this way. See if I can get out of sight for 5. Oh, he found me again, so now it's gonna chase me down this hall. Oh good, it's still chasing, that's good. Now it should still chase, yep. So now I might be able to lose it in some of these corridors. Let's see if I can go up here. Nope, he's still gonna get me. Oh. Ah, so it cut the corner, which was nice. That was a nice optimization. That's good. Good to see that. And I'm not gonna be able to lose this guy, because now he's too close. There's no way I'm gonna shake him. So he's just gonna... But he's also... Let's test the kiting. So before he would not... So if I start moving to the left here, with the previous algorithm, I think he would just kite with me. Oh, we haven't implemented that yet, so he's just going to still kite. So that's the behavior that we want to eliminate with this next bit. But the giving chase appears to be working. We'll have to see if he actually stops chasing. We'll have to test that. But it appears that everything is still working as expected. Oh, thanks, Core the Bird. I appreciate it. Yeah, I'm kind of happy with how it's coming so far. You a fan of roguelikes? Okay. Let's go and implement that second bit of behavior now, which is this: evaluate the cardinal directions and pick randomly between the optimal moves. Oh, jeez. Control... I don't remember how to get back to where I was. There's a... Jump back. Alt minus. That's what it is. Okay. Alright, so... We're going to create a list. Moves. Let's call it moves. And it will be... It's been a while since I looked at my list implementation. List. Where's our API? So we do list... init, and we return a list pointer. And I think we just give it the destroy, a pointer to our destroy function. You know, oh, you like, is it Yvonne or Ivan? I know that there's a big, yeah, it's super, isn't that the whole point of that particular game? It's like stupidly hard. Like over the top. I haven't actually played it, but I listen to Roguelike Radio, which is an excellent podcast. If you guys haven't heard of it, check it out. They They do it about once every month, or sometimes they'll do every 2 weeks or so. But they discuss various roguelikes, and they have different roguelike developers on, so it's a pretty interesting program. But a while back they did Ivan or Yvonne, and they were just talking about how incredibly difficult it was. So we're going to send it. This is just going to be a. We'll just use free to deallocate the memory allocated by the list. And so to add to the list, we just do list insert after. That's what it is. And we give it a list element. And I really need to get back to doing this more regularly because I have to figure out what I've implemented in the past and how my own data structures work every time, which is kind of embarrassing. Let's find another usage where I'm using it. Am I not? Oh, I'm using it in my map function, I believe. Here we go. It's my hallways. So I do a list init and then list segments. I'm looping through them. So in this map get segments is where just inserting S. Okay, so it's just a perfect. All right, so in this case we're going to grab new position.
They had no time for me. Their eyes were all looking down at their numbers.
Let's see if we can count this. So instead of we're gonna build this out a bit. So instead of just returning a new position or altering the position, what we're going to want to do is this is an optimal move, so we're going to want to add it to our list of moves. So we'll do we're going to create. We'll basically push new position onto our list. So we'll do list insert after. And list insert after takes a couple parameters. It takes the list itself that we're inserting into. It takes the element, the element that we're inserting after, and we can give it null to push it onto the head of the list, which is fine for our purposes. And then we give it the data. So we'll do the list we're pushing it onto is moves, and we'll do null, and then we're going to push our the new position structure, which will create it. So we'll do. I think we're already using E as a variable. Let's do it. Call it NP. And up here, do. copy this. Say np new, and then we'll say np dot x minus equal 1 for this particular case. And so we're going to want to do the same similar things for the rest of these cases. How's everyone doing this morning? We can actually take this out of... Oh, we want... So in this case, we're doing y plus equal to 1. This is x plus 1. Perhaps the list is a bit overkill here, but so y minus 1. All right, so what we're doing, I can get rid of this to do. We create our list, and we're then looking at the target map and looking for optimal moves. If we find them, and this shouldn't be else, this should be, that's the other problem. We should just be doing ifs, because we would like to test all of these conditions and see which optimal moves, or we want to find all the optimal moves and put them in the list. So when we finish with all of these checks, we should have a number, one or more optimal moves in our moves list. So I think we have a count, or we have a size, list size. And what we're going to want to do, wait, what does that return? This size is a U32. So, move count is list size. Perhaps we don't even need to. Can I? Really? Really, I could just make do with an array here. Should add a list element at, it should take a, should be able to index into that list. We can enhance that. Alright, so we have got our move count, and then we'll do, we'll say, move index is going to be random, and then we're going to mod the move count. So really, we should probably just do this, because we don't need extra variables that are used immediately after they're assigned to. So anyone out there that's interested in ASCII roguelikes or roguelikes in general, I would appreciate a follow if you'd like to get notifications for the next time I stream. I try and stream at least once a week, as my schedule permits. I used to stream a couple weeknights a week, but it's gotten busy lately, so usually it's once a week. But I'd appreciate the follow if you guys are interested. So move index, we're then going to want to pull the item at move index from our moves list and then execute that particular move. So Core the Bird, thanks for the follow. I appreciate it. So basically I want to assign whatever that is into new pause. So let's see if we can, let's write the code that we'd like to be able to use. So we'll just say new pause. But I think I hit enter there, but okay. New pause is equal to, we'll do list item at, and then we can say move index. We'll give it our list, moves, and then move index. Because we'd like to be able to grab a particular item right out of our list, or grab a reference to it. So we'll do list item at, new pause, and then we fall out of this loop, and then we check and see if the position can be moved to, and if so, then we'll move. I think that what IDE? This is Sublime Text. It's just a text editor. It's available on Windows and Mac, and it's pretty awesome because it's extensible. There's a ton of modules that you can plug into it. You can write your own modules in Python and build it out. Yeah, it's called Sublime Text. Okay. All right, so we're going to need to go add a new function for our list because we don't have any way right now to get an item at a particular index on the list. So I don't think we do, at least. It's been a while since yeah, there's nothing in here. So we will do, let's just do it right here. We're going to be returning an item, and so we'll do void, called it list item at. We're going to send in our list, pointer to our list, and then we're going to send in an index into our list. And so let's do the, where are we? We're gonna do, can copy some of this stuff. We'll do void data, let's see. Star data equals null. We'll return null if the index is outside our bounds. You think I can make a game like Owlboy with C? I'm not familiar with the game Owlboy, but you can do pretty much anything you want in C. There really isn't a type of program that I can think of that you couldn't write in C. Since C is much lower level, much closer to the actual machine, as opposed to a higher level language, it may take you longer in C. But it will give you complete control over what you're doing and control over. So, I mean, higher level languages, you may end up being more productive off the bat. But if you are looking for true performance and being able to get at the metal, then C is a great option for that. I'll look up Owlboy. But like I said, you can make any program. Owlboy game. Yeah, I mean that looks. Is it like a platformer or something? It looks. Yeah, graphics framework. Graphics libraries, graphics frameworks can certainly lighten the load. For this, yeah, I'm building an ASCII roguelike right now, so I'm choosing to do kind of everything from scratch. But I am using SDL, SDL2 specifically, as my as the library or framework that allows me to access the hardware, or the graphical hardware. It kind of abstracts some of the graphics layer, but I'm still basically writing to pixel buffers and then telling SDL to render it to the screen. But SDL handles some of the cross-platform stuff that I really don't want to have to deal with right now. So like this will build. I'm building this on Windows right now, but I've also built it on my Mac. So it is cross-platform. C can absolutely compile the exe. It can compile. C is. It will support Windows. C supports Unix. It supports Mac, which is Unix under the hood. It'll support all your consoles. It's really a matter of getting the right. Getting the right frameworks or the tools for that particular platform. But Windows itself is written in C. The operating system itself is written in C. So, all right. So list item at. Let's start at. Basically, I want to loop through. My list. So I do U through 2, current index. It's going to start at 0. And it'll be. Is C++ a better option? That's the type of question that could start a language war, and it's personal opinion, really. C++ has some things going for it. It has some things that are not. Yeah, like Core the Bird says, it's whatever language you're most comfortable with. It's whatever language you think you're going to be the most productive with. So if it's your very first introduction to programming, C might not be the best option. In terms of learning kind of the higher level logic behind programming. I would suggest a lot of 101 courses in college these days teach Python, which is a good language for learning programming and learning some of the computer science behind programming. And then you can, once you're comfortable with programming in general, learning a new language is not a monumental feat. So. Alright, let's, I don't have a ton more time, so let's wrap this up. Let's do, I'm basically going to loop through my list, and I'm just looking through some of the stuff here. I don't even remember what this structure has in it. So I've got a pointer to my head, the tail, so I guess I'll start at head. Let's say list element. Equals alright, we'll start at head. Hey, Mr. Love Pickle, how's it going? I have been streaming less, which is a bit disappointing, but it's been a little bit busy in the evenings. Usually I stream evenings. Hey, le Theorician, is it French? But I will try and get back into the swing of things because, as you can see, like the less I stream, the more time I spend each stream trying to figure out what it was that I did before. So yes, I definitely need to get better about streaming. It's lack of time and my current Rocket League addiction that is biting into my streaming time. Darn that Rocket League. Okay, so we'll do while current element is not null. We're basically going to loop. While it's not null, and what do we want to do here? I guess, yeah, we can have a break. So we'll do, we'll say current element, or current index. If it's not null, we'll say if current index, gosh darn it, is the index that we're looking for, we will return current element. And then we'll bump current index. And we will move current element equals next. Right? I think it's next. Is it next element or next? It's next. Alright. Alright, so we start at the head of the list. We loop until we have until we hit a null. We check our index. If the current index is the desired index, we return the element that we are currently pointing at. Otherwise, we bump the index and we move to our next element, which I think should be okay. If we fall out of the loop, we're going to return null, which means that we asked for an element that was greater than the size of our list, or asked for an index that was outside the bounds. How's everyone doing today? I've probably only got about 10 minutes left on stream. I apologize for that, but let's see if we can finish what we're doing. So now we've implemented this list item at, so new position should get one of our optimal moves. So let's see if we've... it's saying list insert after the actual parameter is not a pointer, and that is true because I need to do this. Send it the address to make it a pointer. And in game 449, it's complaining, oh, this is a pointer. Can I do that? No, that's not. Oh, right. This is what I've done. Position. So what I need to do, this is position, it'll return a position pointer. And so then what I need to do is take the value of that. Alright, so let's see what we've got. So this, remember, we just implemented a fix for that kiting effect that we were seeing. So let's find one of our beasts. One of our fantastic beasts. Where will we find them? Wow, they're well hidden today. We only put 3 in there, so sometimes they're a tad elusive. There, okay. So there he is. So now it looks like it's not working because he can see us. He should be moving towards us. And so it's clearly not working. Oh, that's great. So they move until they see me, and then they just freeze in their tracks. Deer in the headlights. All right, let's see if we can figure out why that's happening. Do I have any prints? I think we might start with the... Core the bird! So our new position, it might just be like we're copying NP, we put those in the list, and then let me just think about item lifetime here. It's still, oh, that's the problem. These things are going out of scope like immediately. Stupid. I need to do, is it a randomly generated map? Yes, it is. Yes, it is. It's procedurally generated or randomly generated each time. So it'll be different each time through. So the problem here is that I'm declaring these position. I really need to make these pointers, and then I need to allocate them. Which is really why I should have just done a list, or just a simple array. which perhaps I'll... This is kind of dumb. Here's what we're gonna do. Instead of doing list insert after, we're going to do moves, move count. Say that equals NP. Instead of using this list, which is kind of ridiculous and has us worrying about memory management and stuff. And then we'll do move count. This equals 1. We can even be smarter about this. No, that'll be fine. Alright, give chase. So now we're going to do, instead of list size, we're going to do move count. And our new position is just going to be moves at move index. Which seems a bit more straightforward and doesn't have us doing memory management and all that goofy stuff. I think that'll build. Yep. Let's see. Okay, he's chasing us. So that's good. But we can't test the kiting effect because he's like right there. Let's see if we can find another one. Oh, he did pick a different optimal move. Look at that. See how he switches sides? So that is a different optimal move. So that the kiting effect is effectively fixed, it looks like. So he's not just sticking to us. Let's see. Man, where are these things? Hello? I need to add more monsters. It's hard to test. They must be up here. Or over here? Okay, there's our snake. So let's start moving side to side and see if he starts. So the optimal move for the snake right now is to move either to the right. As I move to the right, it's either to move to the right or to move towards me, down. So with our previous logic, the snake would have just kept moving in parallel to the right as I moved. And so, oh, see, okay, so now it moved down. So it does look like it's moving optimally. That's good. Okay, so it looks like that did what we wanted, which makes me happy. So we've accomplished a decent amount today. We made it so the monsters will only chase us if they've seen the player, or while they're seeing the player, or if they've seen the player in the last 5 moves. And they will now move in a still optimal but less predictable way. So if there are multiple optimal moves, it will pick randomly between them. And then if the monster is not actively chasing the player, then they'll just move randomly. And I appreciate the follow, Le Theorician. It's a bit tricky to say, but Le Theorician. Yeah, if anybody else is interested in getting notifications the next time I stream, please hit that follow button. And I think that might do it for me today. Like I said, a bit time box today, a shorter stream. But next time, let's see. I think what we're going to do is I want to overhaul the entity management system, and I guess not overhaul is maybe perhaps too strong of a term. I want to change it so it's a little bit more efficient memory-wise, and a little bit more efficient when trying to access certain components. Renkro, thanks for the follow. I appreciate it. So right now, the world state is kind of a bunch of statically declared arrays, and so there's a couple problems with that which we can go into next time. It wastes some space, and it also causes some of our loops when we're trying to search for particular components. It causes those loops to be less efficient. So I'm looking at converting all of these component arrays to dynamic lists, and only needing them to be as big as they have to be, which should hopefully improve memory performance and also improve lookup performance. And then one other thing I'd like to do is implement a custom lookup for our position component, because that's kind of unique in that it needs I really would like to be able to say, give me all of the items or objects at position XY, and not have to loop through all my positions comparing against X and Y. I'd like that to be more efficient. So those are some things that I'd like to look at next time. And then very soon after that would be implementing a text file to hold configuration for our monsters, so that we can define the monsters in a text file. I haven't decided on the format for that, whether it's going to be YAML or JSON or just a simplified structured format of our own making. But I'd really like to get that added so that we can spin up monsters based on that config file. And yeah, so just looking over here, making sure we can spin those out from a file. Oops. And then enhancing the dungeon generator to place monsters, and then soon after that you can see is combat. So actually having the monsters, instead of just stick to us like glue once they're at their optimal distance, actually like swing at us and hit, and build that stuff out. So I think that is going to do it for me today. Thanks everyone for watching. Again, the archives of this stream and all the previous streams are up on YouTube, or this one will be up soon. If you want to hit me up on Twitter at PDCodes with any questions or comments, and then if you'd like to grab the source code for Dark Caverns and play around with it yourself, or just follow along, it's up on GitHub at the address listed there. Be sure to hit that follow button if you haven't already to get notifications the next time I stream. And I hope everyone has a good day. Thanks for watching.